Welcome back. We are still on the topic sequence and series. In the previous video, we solved a question on finding the common ratio of a GP. In this video, we are going to solve another question. The question for this video is, the second and fourth terms of a GP of positive terms are 8 and 32 respectively. Find I, the common ratio, II, the first term. We have learned that the value of a term in a GP is denoted by UN, and UN is given by the formula AR exponent n minus 1, where A is the first term of the GP, R is the common ratio, and n is the number of the term whose value we want to find. The question wants us to find the common ratio and the first term, so we are looking for A and R. From the question, we are being told that the second term and the fourth term are 8 and 32 respectively, meaning that the second term of the GP is 8. The second term of the GP will be denoted by U2. So U2 is equal to 8 since the second term is 8. We are talking about the second term, so the number of the term is 2. So it means that n is equal to 2. Let's find U2 from the formula. From the formula, U2 will be equal to AR exponent 2 minus 1 since n is equal to 2. So we have U2 is equal to AR exponent 2 minus 1. We know that U2 is equal to 8, so we can replace U2 here with 8. And we will have 8 is equal to AR, since 2 minus 1 will give us 1. And R exponent 1 is the same as R. So 8 is equal to AR. We have AR is equal to 8. We also know that the fourth term of the GP is 32. The fourth term will be denoted by U4. So U4 is equal to 32. We are talking about the fourth term. So the number of this term is 4. So n is equal to 4. Let's find U4 from the formula. From the formula, U4 will be equal to AR exponent 4 minus 1. U4 is equal to 32. So we have 32 is equal to AR exponent 3. Since 4 minus 1 will give us 3. So we have 32 is equal to AR exponent 3. This can also be written as AR exponent 3 is equal to 32. So we have two equations here and two variables. I'll call the first one equation 1 and the second one equation 2. We have two equations, two variables, so we can solve these equations simultaneously. Once again, equation 1 is AR is equal to 8, and equation 2 is AR exponent 3 is equal to 32. I want to eliminate A from these two equations. In the first equation, A and R are multiplying. In the second equation, A and R exponent 3 are also multiplying. Because we have multiplication in both equations, I'm going to divide one equation by the other in order to eliminate A. So I'm going to divide equation 2 by equation 1. Equation 2 divided by equation 1. I'll take the term on the left-hand side of equation 2, which is AR exponent 3, and divide it by the term on the left-hand side of equation 1, which is AR. And this will be equal to, then I'll take the term on the right-hand side of equation 2, which is 32, and divide it by the term on the right-hand side of equation 1, which is 8. So we have AR exponent 3 divided by AR is equal to 32 divided by 8. We know that in this case, A will cancel A. So on the left-hand side, we are going to have R exponent 3 divided by R, and on the right hand side we will have 32 divided by 8. From indices, we learnt that R exponent 3 divided by R is equal to R exponent 2. 32 divided by 8 is equal to 4. So we have R squared, or R exponent 2, is equal to 4. We can rearrange this as r exponent 2 minus 4 is equal to 0. 4 can be expressed in index form as 2 exponent 2. So we have r squared minus 2 exponent 2 is equal to 0. From algebra, we can see that this expression on the left-hand side, r squared minus s squared, is a difference of two squares. In the videos on difference of two squares, we learnt that an expression of this form, that is r squared minus 2 squared, can be expanded as r minus 2 in one bracket, then r plus 2 in another bracket. I explained this into details in the videos on difference of two squares and the algebra. So if you want more information about difference of two squares, watch the video on difference of two squares and the algebra. Let's continue with our solution. We have learned that when you have an equation like this, in order to find the values of r, you equate the content of the first bracket to 0, then you equate the content of the second bracket also to 0. So for the first bracket, we have r minus 2. So you equate that to 0. So we have r minus 2 is equal to 0, and this will give us r is equal to 2. You do the same thing for the second bracket. We have r plus 2. So you equate that one also to 0. We have r plus 2 is equal to 0, and r is equal to minus 2. So you can see that from here, we have two values of r. R is equal to 2 and r is equal to minus 2. But remember that in the question, we were told that the GP has positive values only. That means that all the terms in the GP are positive. If all the terms in the GP are positive, then it means that the common ratio should be positive. Because if the common ratio is negative, then some of the terms will be negative. We know that from the question, all the terms in the GP are positive. So because all the terms in the GP are positive, then it means that we are going to pick the positive value of r. Here, we had two values of r. One is positive and one is negative. Because all the terms in the GP are positive, we are going to pick the positive value. So we can say that because all the terms of the GP are positive, then r is equal to 2. From equation 1, we know that AR is equal to 8. So if R is equal to 2, then we will have A times 2 is equal to 8. This will give us 2A is equal to 8. So we divide the left hand side by 2, we divide the right hand side by 2, and A will give us 4. Remember that R is the common ratio of the GP and A is the first term. We have found r to be 2 and a to be 4. So we can say that the first term of the GP is 4 and the common ratio is 2. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the common ratio of a GP. Bye-bye.